Thanks everyone for coming. It's a beautiful day out there, so I know it's a bit of a challenge to be in here. I knew I had a challenge in my hands when I saw the schedule for this session. Not because I'm going against some amazing speakers in the other room, but mainly because I know it's just after lunch, so I don't want you to fall asleep while I'm talking. I'll try to keep you all awake. That's my goal. So let's get started. My name is Christos Matskas. I work as a software consultant. I've worked in a lot of different projects, mainly around the .NET stack. And I've worked in teams that had just one person, me, doing mobile apps, all the way down to much larger projects with tens of developers and a lot of teams spread across the globe, different time zones and different cultures. And when I say tens of developers, I don't mean 11 developers, I mean a lot of developers. So today I will be talking about test-driven development and the things that can go wrong, or the mistakes that developers do when they use TDD in the development approach. Then I will expand a little bit and make a reference about the larger issues that we deal with TDD when it comes to development. And I will close off with some suggestions about how we can use TDD to make it better for our development process and how we can use TDD to make it better for us. I would like to start with a brief explanation about what TDD is. I know that there have already been a few sessions today or yesterday that were talking about TDD. I'll try not to spend too much time on that. But for those of us that don't practice or that haven't heard about TDD, for those developers that have been living under a rock or have been developing in the basement for the last 13 years and haven't had any human contact, TDD is a development approach that combines test-driven or test-first development with a continuous refactoring process. Now, by test-first, self-explanatory, you write your tests first before you write any production code, and that's the way that you use your tests to drive your implementation. And by the continuous refactoring, I mean the idea of using the red-green refactoring cycle, where you start with your tests first, and you write a bit of code, then you write a bit of more tests, and then you write a bit more code until you implement just the right stuff, just the right amount of code that will allow you to implement the feature that you need. There's another important thing that we need to do is to clarify what TDD isn't. Now, some people tend to confuse TDD with unit tests, and that's not right, because TDD is actually driving, or is used to drive unit tests, but they're not the same. Your unit tests are used to evaluate your code and make sure that it does exactly what it's supposed to do. Test-driven development is not unit tests. So you need to make that important clarification. TDD tests are also not user acceptance tests. Now, I've seen this in the past where companies have a very comprehensive tests of TDD tests and unit tests. And they say, right, our TDD is quite comprehensive, we cover everything. I think we got good production-ready code, let's ship it. That's not the case. User acceptance tests are there to validate behavior of your application. TDD is there to help you with the design of your application. Now, knowing what TDD is and what isn't, I would like to explain a little bit about what TDD can do for us before we start buttering and saying what TDD can go, how TDD can go wrong. So first thing first, we got small, concise pieces of code. The idea is that you write minimal tests and then minimal code to satisfy your test. Then you expand your tests, and then you expand your code based on that. As soon as you reach the optimal size, which is the minimum amount of code that satisfies your requirements or your functionality, you stop. No more, no less. Small pieces of code, small chunks. It can help us have short feedback loop that continues report on our unit tests through our automated tests or through our test suite, allow us to have a clear idea of what can go wrong or what goes wrong. As soon as you add a new feature or as soon as you add some code to fix a bug, then your unit test should let you know whether that has failed or not. That short feedback loop means that you don't have to wait for 30 lines of code in your function to see whether you failed or not once you started writing your tests. Another benefit is that it helps design specification. It allows you it forces you to think about how to write your unit tests. And that, in effect, forces you to think about how to design your code, starting from the small and specific to the overall and larger. Then that's how you do your design. And that's one of the greatest benefits of TDD. Too many. Reduces time to do bug fixes and adds new features. Again, this is related to the short feedback loop, but there's been a lot of research and we've tested real teams, and we found out that teams that adopt TDD as their development approach, in most cases tend to be a lot faster when they have to close items and when they have to close tickets or bugs and implement features. So it reduces the time that it takes to fix something. And finally, it reduces the time that you spend in your debugger. Your tests are there to give you immediate feedback on your stuff. So by having a comprehensive suite of tests, it means that as soon as a bug is introduced or as soon as something breaks, your test can indicate where things go wrong. By that, you can identify the piece of code that doesn't work as expected, go and fix it. At that point, you fire up the debugger, you find the line of code that misbehaves, and you fix it. You don't have to go through the full path of firing out the application, going through the fail path to figure out what it is. You spend a lot less time debugging and a lot more time writing code. And finally, it makes your code a lot more adaptable. TDD drives unit tests, and unit tests give us confidence. By confidence, we can start adding a lot more refactoring in our application, and we can be a lot more confident when it comes to respond to the ever-increasing needs of the business. By that, I mean it's easier for you to implement a new feature or fix a bug because your code is giving you confidence. I'll give you an example about that. I was working in a project recently where we had an ASP.NET application, web forms, and that web forms page had not a single line of ASP. It was all driven through JavaScript. There were 1,800 lines of uncompiled, untested JavaScript. Not a single test. And that JavaScript would do multiple calls to the backend, get data from the API, and use that data to drive the DOM. Every single element in the DOM had to go through a number of AJAX calls. That was absolutely appalling. Now imagine my fear when I was told that I had to go and add a text box. Now, on that form, adding a text box meant I had to go through all the JavaScript code, figure out what had to be done, and then drive all that down to the database and all that back through services and all these layers without a single line of unit test. Now, who would feel confident about touching that piece of code? I'm pretty sure nobody would do so. TDD and unit tests do improve our confidence, and that's a vital thing to have. So we've seen what we've seen what TDD can do for us. But unfortunately, as with everything else in coding, there's no one true path. There's no one real solution to a problem. And with so many things open to interpretation, it's quite easy to lose track of what's happening and what's not. It's very hard to justify whether something that you've done works the right way or the wrong way. So, next I will be talking about things that can happen or things that developers do wrong when they approach TDD or when they adopt TDD in their development process. One of the biggest things that I found is not using a mocking framework. You would expect people to be adept and understand what mocking can do for them, but there have been cases where we know that unit tests need to run in isolation, we know that unit tests need to run as standalone pieces, and things need to be abstracted through mocks and fakes and stubs. Now, the worst thing you can do is not use an established mocking framework. Some developers choose to roll their own manual mocks, which works absolutely fine if you want to go down that route. You just have to invent the mocking frameworks that are already there for you, written by a lot smarter people than you. As an example, I worked in a company where we had a large project assigned to us. It was an exciting project, greenfield, all new stuff, but hence, against common logic, we decided to implement mocking in a very convoluted way. Rather than using a mocking framework, we decided to create our own test concrete implementation of every single interface. And you can imagine how this can go wrong when you have 50 or 60 interfaces that have to be implemented both in production and in test code. Every change in the interface had to be changed in 2 different places. We ended up with a lot of test code that was empty methods because we didn't really need to test them, and it became a maintenance nightmare. It would have been a lot easier for them to have implemented a mocking framework, and I would have spent a lot more time watching cat videos on the internet. Unfortunately, that didn't happen. So, the next thing that tends to happen quite frequently is too much test setup. From having no mocking framework to overusing your mocking frameworks. It's very easy, mocking frameworks make it very easy to over set up things. And with objects in our code base that have multiple dependencies, I've seen code with 9, 10 dependencies, all having to be mocked out, and knowing exactly how many methods and how many interfaces you have to mock out until your TDD test can run in full success, it's quite hard. And it's quite easy to go overboard. So, asserting everything. You should be able to describe your test, the assertions of your test methods without using AND. If your method sounds like test that you can get by ID and username is blah and his age is 3, then you are doing it wrong. There are too many assertions there, and that will make your code a bit harder to test. There are a lot more chances for your unit tests to fail, and it will make it harder for you to maintain your tests. In an ideal world, you want your test to have a 1-to-1 mapping, so 1 unit test to 1 assertion. Now, obviously, that will add some bloat. That will make your code a bit more expanded, but in effect, you gain readability and clarity through your code. So yes, it makes things a bit more hard to implement and adds a lot of code, but obviously, the gains that you get from the clarity are a good counterweight. Now, necessary testing. Obviously, there are so many areas in our code that we need to test. It's very hard to judge where to run your tests and where not to run your tests. I'll use this example as a pointer. Now, we already have a student service that calls into a student repository service, which has already been mocked out or has already been tested by another unit test. Now, do we really need to test the get by ID here? We already know that the repository, the student repository, will return the right object. So by testing this again, you not only add duplication, but you add time and effort to write your tests, and it will also add to your maintenance further down the line once things change. It's very important to choose the right things to test at the right time. So I've gone through the big issues with the issues that the developers face when they do TDD. They're quite common, and I'm pretty sure some of us have already fallen into the trap. But I think there's a larger issue when it comes to TDD. These issues have been summarized here for you, and they are based on my experience and talking to different teams. I'm pretty sure that some of you may agree or disagree with that, so I'm more than open to a discussion afterwards if you fancy doing that. So, false confidence. No, TDD is, unit testing is all about confidence. Developers need to feel confident about their code, and that confidence needs to derive from a comprehensive set of unit tests and reasonable code coverage. TDD should not be dictating whether we feel happy or sad about our code. TDD should not be the true path to code confidence. Now, there are some people out there that are the TDD advocates that say, but obviously testing can be bad, right? I mean, we have everything we need to test here, so why could that be bad? Obviously, by forcing developers to go down the TDD route, sometimes you get a bit of a class. Sometimes you have unnecessary friction, because if you have the team leader or the company forcing down TDD the developer's throat, and then the developers push back by saying, you know what, TDD is dead, it doesn't really work for me, then you have that friction that doesn't need to be there. You need to be able to feel confident about your tests, regardless of whether you use TDD or not. Now it's a sad case, but I've seen teams where TDD was forced down to them, and some of them were coming up saying, look, I'm happy to do TDD, but I'm feeling a bit bad because it doesn't really work 100%. Sometimes I can do TDD 50%, 60%. Sometimes I can do more, but sometimes I do less. The company has needs. I have to implement features. The sprint is moving along. There's time and cost constraints. So I can't do 100% TDD. It's not good. I do go back though, and I do fix my unit tests. So is that something that developers should feel guilty about? Does it really matter whether your confidence comes from a test that you've written prior or after the fact? I think TDD is one way to feel confident about your code, but a comprehensive set of tests and reasonable code coverage is what really, really matters. Testing too much is expensive. Testing is fantastic. Having tests there, it gives confidence to the team, it makes everybody happy, and it promotes good code practices. Discovering TDD for the first time can be a revelation. It can be opening the door to a whole new world. You get obsessed by the green. You want to write tests. You want to test everything. Add on top of that your automated coverage tools like nCover and nCrunch, that they give you instant gratification and instant feedback about how your code behaves. And then you suddenly have developers that try to overdo it, try to cover every single thing under the sun. This is also quite prevalent with newer developers or inexperienced developers that have no guidance about what needs to be tested and what not. And eventually you end up trying to test everything. Now, obviously testing too much can be too bad, you may think. But unfortunately, in the real world, testing costs. It's a noble goal to have, and it's a nice thing to have, but unfortunately testing too much can hamper the performance of the team. Now, every single line of code that you write has to be written, has to be tested, has to be read and understood by everyone in the team to make sense. So for your code, not just test code, to make sense, it needs to give more back than it takes to write it. If it takes more to write your tests rather than it takes to get out of it, then obviously it's counterproductive and it can be costly for the team. Test-induced architecture challenges. Now we've already mentioned that TDD can help us drive design. The TDD mantra is that code should be easy to test first. Our unit tests need to be small, concise, and fast to run, and should be run in isolation. By using the TDD approach of do as little as possible to get things done, it means that we can actually damage our architecture design by unnecessary indirection and conceptual overhead. TDD is good and advocates want to push that down, but unfortunately, sometimes that creates a lot of friction, that creates a lot of problems, and eventually your design suffers. When going through the premise, then you write your code in a way that needs to satisfy the unit tests. Your architecture is going to suffer because it doesn't focus on the bigger picture. It focuses on the fact that it has to satisfy the test criteria. It has to satisfy and make happy your test framework. As such, it would probably make sense to say we should sacrifice in the altar of TDD and its continuous red-green cycle. All the architecture design, use that to drive everything. But unfortunately, in the real world, this can have some really dreadful effects to the overall application performance. We should always think about how to do our architecture, not based on the testing framework that we use or the test needs, but the actual business needs and what the application should be doing for what it needs to do. Heavy mocking. I've already spoken about mocking. We've seen that some teams choose to do a lot of mocking. Some developers choose not to do any mocking whatsoever. But this is a bigger idea. Now, we already discussed about the fact that a unit test need to run in isolation. We discussed about the fact that the test needs to be fast and efficient. And as such, we need the application to be able to, or the infrastructure of our application to support this. Now, if you are going to use a mocking framework, then your application needs to have the right, needs to meet the right criteria to do so. So certain mocking frameworks require you that you have interfaces implemented, because otherwise they can't mock anything. You have a specific IOC or dependency injection in there, and so on and so on. In effect, you might add load to your application, and you might make the architecture a bit more complicated, only in order to use TDD. So it needs to be balanced out. TDD in the real world, that's probably one of the most realistic or pragmatic things I've come across. We know that a TDD is established. We know that TDD is out there. Everybody knows about TDD. When you apply for a job or a contract, one of the tick boxes is you need to be able to do TDD. Now, obviously, most of the companies out there that can't really distinguish between TDD and unit tests, because everywhere I've been, I requested TDD. Not a single developer was developing in pure TDD. Let alone some of them didn't have any unit tests. So let's ignore that one. So TDD in the real world. In an ideal world, you would join a project or a team that have already been working in a TDD practice, or you might be joining a greenfield project where you start from scratch and there's nothing in the code base. And that's where you can truly apply the TDD ideas. However, when you join a team these days, in most likelihood, you will be joining a larger team that has an established code base, that has a lot of code out there, and you're called to help add more features or fix bugs or take it to the next level. Now, obviously, you're excited. You say, you know what, I'm going to go all TDD out on this thing and make it better. So you're assigned your first task. You open up the code base, and suddenly you are presented with three things. If it's all TDD and it's working fine, then we can disregard that. It's brilliant. However, in most cases, you'll find a few unit tests that provide a bit of code coverage, maybe 25, 30%, which is quite nice, but a lot of things are missing. Or you'll find no unit tests, which is the other nightmare. However, if we take the scenario of 30% unit test, 10% code coverage, a few unit tests out there, you start to realize that you want to add your features in TDD mode, but unfortunately the infrastructure doesn't support it. So what do? There are two options there. You either do your bit, and you go and fix the stuff that you need to implement. You fix the bug, you add the feature, you add some unit tests by extending the existing unit tests, or you add some unit tests on the feature that you're working on, and you move along. Or you decide to start ripping things apart and start implementing interfaces and trying to make the application to work that way to do TDD. Now, in any code base that has more than a few thousand lines of code, that's going to become a nightmare. You're going to end up with two different streams, and you get certain people in the team working in the TDD stream trying to move that along, and then you have the other people in the team trying to fix the issues on the existing code base. Eventually, in most cases, businesses will say, we don't have money, we don't have the time, scrap TDD, make it work. And this is the sad scenario. I've worked in a lot of teams and I've worked in a lot of projects. I've only been lucky to use pure TDD once. And it's very hard to try to yield your application to make it work in a pure TDD way, only because of the constraints. If you want to do pure TDD, then you're guaranteed to almost fail unless you start rewriting the whole thing from scratch. And finally, not everyone can think in the TDD terms. Think, as I said, I've worked in a lot of teams, I've worked with a lot of people, and when I ask them, why do you not do TDD? They go, it doesn't work for me, man. it's not the same. It's hard for me to think those terms. I've tried it, I've done it a little bit. It's not the way I solve the problems. It's fine for some people. Some people can go from the very specific and expand. And that's how TDD works beautifully in that scenario. However, in most cases, you go from, you got this feature that you have to implement, break it down in small pieces, start implementing stuff, write a few unit tests around it, then write the full unit test suite around your feature, and you're done. And to me, I think that's more like a 70-30 split. 70% of the people like to think that way. I don't know if it's because we've been cultivated like that or because we've grown through our processes and teams and development to work in that way. But changing your mental thinking takes a lot of effort and a lot of time. And in most cases, teams, companies, and even the people themselves don't want to change that process. So yeah, TDD is beautiful, TDD works, but it's not for everyone. So it's very disheartening when you see PMs and teams and companies saying, right, we're doing TDD, you're going to do TDD, otherwise your code is not going to be accepted. So, how can we make TDD work for us? Can we make TDD work for us? That's the other question. Do we have to be pure TDD 100%? Or can we just mix and match and make things work in a better way? And I think we can. I am a pragmatic person, and I like to use the right tool for the right job. As I said, in most code bases that you'll join, you'll find out there is no way for you to implement TDD without going through a hell of a maintenance and refactoring. On the other hand, it doesn't make sense to try to apply TDD on everything. It doesn't make sense to test everything. Let's take MVC for example, model view controller. You got 3 components there, and I think only one of them can be truly tested or should be tested, and that's your model. When it comes to the controller is there to take the requests from the user, pass it on to the application, and then relay a response back to the user. As such, we know that controllers have a lot of dependencies and they have a lot of coupling, in which case we'll have to use a mocking framework on top of everything else to mock out a heap of modules and dependencies for the controller. It makes a lot more sense to test your controllers through integration tests, because at that point you already know that your service is working. You're not duplicating the get by ID or get users by calling the same test method. You're eliminating your testing there, and you're also testing your controller through integration tests, which are better suited. On the other hand, we have your view, which sits at the top of the stack, and as such, it's more like a presentation layer rather than a functional layer to the application. It makes no sense for us to unit test the view. It makes a lot more sense for us to do user acceptance testing and UI testing, end-to-end testing for our views, because this is where the true test lies with the views. It's the presentation layer, it's what the user sees, it's the behavior of the application. Right, so I will try to add some suggestions here about how we can make TDD and how we can make testing work better for us, and then I'll open the floor to questions. So that's the example I was going to present here. There's no point of us using the unit testing that controller because we're the testing stuff in the services. Code to test ratio. Yes, writing tests for every single thing under the sun can be good, but we've already said that there's a large cost, time, and investment added to the tests that you write. The more tests that you have and the more lines of code you have, the more maintenance you have to do. In an ideal world, you want for every method you have to implement, you have a test ratio of about 2. So 1 method, 2 tests, 2 nicer sessions. That gives you good confidence on your function. Anything more than 1 to 2 will probably add code smell, which in effect will add technical debt and problems later on. Find the right coverage ratio. Don't aim for 110%. Don't aim for 100%. Don't even aim for 95%. Aim for 75%. Tweak the rules, make them work for your team. It's like style code. People avoid to use style code because it goes mental as soon as you add it into your solution. You don't have to go with the default settings. Find the right settings for you and make it work. If you don't like your methods to be at the top and you like them at the bottom, Agree with the team and make it work. It's the same for your code coverage. Don't aim for 95%. Aim for the stuff that makes sense. Don't let your PMs or your managers push you down saying, no, you only have so much coverage. Push back and say, this doesn't make any sense. This is why we're doing this. This is why we're adding integration tests. That's why we're adding unit tests. And that's why we have UI tests. To make sense. Tests should take less time to write than it takes. Tests should take less time to write than it takes to write your code. If your tests take longer to write than your code, then you're doing it wrong. The tests are there to support your code. They're not there to drive everything. Don't try to drive everything through your tests. Keep a clear separation between unit tests and integration tests. Again, I'm mentioning that. It's very important to know what you're testing and why you're testing it. Don't test your controllers. Don't test things that are better suited for integration tests. It not only adds duplication, it causes time and effort. In effect, you're going to be the one maintaining all those tests. And find the best approach to code first. I don't say don't do TDD. I don't say just do TDD. Find the right approach to you. For some people, it might be a 20-80, right? If 20% of your tests first, drive your solution, and then add the 80% of your tests at the end. Maybe you like a 60-40 split. It doesn't matter. Find things or find the ratio that makes you happy. Gain your satisfaction back from writing code. Because there's a lot of people that try to do TDD and then they feel really guilty about not writing all their tests first. They feel really guilty about doing that 80% and then not leaving that 20% out. So you need to make TDD work for you in the best way. And that's me. So, any questions, guys? Yes?
You said quite early on, trying to keep a single cert in a test.
Yes.
I keep finding that when I'm writing my setup, I'm quite new to TDD, so I always want to assert the setup before I even get to run the test. Am I going about the wrong way? I feel like I want to assert that my setup is correct before I even start calling the code of the test, and then finally do the search.
So just for everybody else, the gentleman over here is asking whether he should be asserting his setup for his unit test before he even starts asserting his actual unit tests. Is that correct?
Yes.
Yeah. So I think you need to find the right balance over there. Usually the setup and the tear down of your unit tests are there to support the unit test, and you should have confidence that that part of the code should work in an expected way. Are you using mocks, for example?
I wasn't in that situation.
Right. Okay.
I was. The example was I was testing some file system.
Yeah.
Framework.
Yeah.
And I needed to create a tree.
Is that a framework that was tested and that was created by somebody else?
No, I just created it myself.
Right, so you create what? So were you testing the actual file system framework, or were you testing?
I was testing the created a folder.
Okay.
I created a folder 2 levels down.
Yep.
And I needed to be sure that I created a test tree.
Yep.
That was correct first, and either I had to insert that in the test, or I had to manually start the test and go and look at the folder and see does it look like a tree that I can then insert from.
I think you should have confidence on your framework or what you've written. So that part of the functionality should already be tested by another test. So when you use that functionality in another test, you already know that that's covered by something else. At that point, you're duplicating your test because you're testing that somewhere else. I'm pretty sure you're testing that somewhere else, but you're not testing it again. You don't need to test again.
It was pretty low level.
It's pretty low level, but just make sure that you test the things that you test, like anti-framework. People go and try to write unit tests for anti-framework. Well, you say no, but people try to do that. And the advice is don't try to test your anti-framework because it's been tested by you by somebody else. When you use a mature framework to support your tests, don't try to test that as well. I said, you don't need to test everything under the sun. In which case, in your scenario, you should have tested that part of the functionality somewhere else, and just focus on the stuff that really matters on that specific test class. Any other questions, guys? Nope. Okay, thank you very much for attending my session, and catch me later on if you have any questions.